If you don't know, I'm Alan Gray, president of the Friends of Taunton Bay. We're happy to see you here. This is actually the seventh Friday night. It's astounding that it's already over. Where did the summer go?
There we go.
I invite anybody who has been thinking about it long and hard to see me about raffle tickets for the canoe. And thank you to the people who did. So Melissa is the education director at CCAR. This is being characterized as a virtual tour of the facility. And your boss says you've been conducting tours for 4 years, are extremely knowledgeable and more personable than himself. So, Melissa.
All right. Well, like I said, I've been here for about 5 years. I'm originally from Arizona, and that was kind of, yay! That was kind of a problem as a child. All I wanted to be was a marine biologist, and Arizona doesn't have an ocean. So I graduated from high school and decided I needed to go somewhere with an ocean so I can continue studying marine biology. So I ended up at the University of Hawaii. Not bad at all. And that's where I was introduced to aquaculture. So are all of you familiar with what aquaculture is? Pretty much? You've heard it here and there. So I started out doing some shrimp aquaculture and something called aquaponics, where I grew catfish and plants together in one system hydroponically in Hawaii. And then after graduating, I wanted to keep doing aquaculture. So I thought, where should I go? Where should I go? I didn't have very much experience. I needed somewhere that would hire me. So I thought, Alaska. And they do. They hired me as a temporary employee to do all the grunt work in a salmon hatchery. So I went up there. I lived in a remote facility in the middle of nowhere, Alaska, pretty much. There were no roads to this place. You had to take a float plane or a boat. And I signed up for a 9-month contract to work as a technician. And before my contract was up, they offered me a full-time job. So I stayed there for 3 years. After 3 years, I decided, I'd really like to be in civilization again. I lived with 6 people year-round, and that was it. A lot of bears. The bears outnumbered the people. So I started looking for jobs. I wanted to learn more about aquaculture. I loved salmon, but the aquaculture techniques used for salmon aquaculture are very simple, and you're just kind of following a recipe, and it always turns out well. So I wanted something a bit more challenging, and I wanted to learn more about something called recirculating aquaculture, which is where you reuse your water, and it's much more complex than the flow-through technology we were using in Alaska. So I kept a lookout, and I saw this job posted for a position here at the Center for Cooperative Aquaculture Research. I applied and I got it, and I'm still here. So let's see, what exactly is aquaculture? Most people, when you say the word aquaculture, they think food. You're growing food. I like to think of that it's a little bit more broad than that. A definition that I like is the production of any aquatic organism for human use. So the production of an aquatic organism by a human for human use. So, of course, we have some delicious food, oysters, which we all love, that are grown in Taunton Bay here. But also marine ornamental fish, and biofuels, and cosmetics. All of those can be derived from aquaculture products. Now this graph down here is just to give you an idea of how aquaculture production has grown over the years. So the orange section, it starts in 1950 and goes to 2014. The orange section is wild caught fish. So you can kind of see it was growing in 1950 and it's kind of leveled off. So wild catches have leveled off. This blue section is where aquaculture has picked up that space, that gap, where the demand for seafood can't be met by all that wild caught production. The U.S. is number 15 in world aquaculture production. We're the 15th largest producer. Number 1 is China, we produce less than 1% of what China produces annually. So we're very small. Maine is actually one of the biggest aquaculture states in the United States, so be proud to be from Maine. So this is our site. Like I said, we're just a couple miles up the road, and we have a pretty big facility. So this facility was built in 1989, and it was a private salmon and Arctic char farm. It lasted for about 10 years. They went out of business, and the university was able to buy it for pennies on the dollar. Great deal. But they bought this facility, and it was full of tanks with fish, and they had to find some people to run it. So the idea behind the university acquiring this site was to promote aquaculture in Maine, and to be able to have a facility where you can do research and teach people who want to get into aquaculture about aquaculture and what it is to do, a way to diversify Maine's economy. So we started out as our own unit, and then we got some neighbors. So the USDA joined us, and they have the National Cold Water Marine Aquaculture Center right next door. And then all together, we are pretty much the most advanced aquaculture research center in the United States. So did you know that? Your neighbors are... So this is our mission, to grow the aquaculture sector in Maine. And we want to do that through innovation, demonstration, facilitation, collaboration, and education. And the way we do that at CCAR day to day is through three main avenues: research, business incubation, and outreach education, like what I'm doing now. We also go out into schools, and we have tours that come by pretty often. So this is a group from a marine science summer camp that came by, and they were learning about some sea urchins. So I'll tell you a little bit about our systems at the CCAR. So we use recirculating aquaculture technology. It's also called RAS. And that means that we reuse most of the water that we use to produce our fish and plants and invertebrates. So all these fish are living in this water and creating a lot of waste. And you have to get rid of that waste somehow. So we have lots of filtration in place. We chose to do this versus the flow-through systems where you're just a constant new flow of clean water, like I talked about that I did in Alaska, because we have more control over all the variables. So when you're doing things like research, you want to be able to control the temperature, the salinity, the photoperiod, the lighting that all the organisms are encountering. So it's really nice to have these systems that are closed loop. You know what you're putting in it, and you know what's going out. It helps reduce pollution and a lot of other things. You can control all the variables. So our first stage that we have is we have a tank with fish or some other kind of animal. And then the water from that tank, the fish eat the food, they do all their business in the tank, and all that uneaten food and fish waste goes down a drain. That drain leads to mechanical filtration. This is the drum filter. So what it is pretty much a barrel that is surrounded by a fine mesh screen. These are 90 micron screens, so really fine mesh. And when that wastewater goes in there, it ends up clogging up all those spots and creating a barrier so the water can't get out. The water level rises in there, which triggers a sensor. And then that sensor makes it run. So it spins in a circle while you can see this spray bar right here. Fresh water comes out of that and sprays down that filter to clean it. So then all those waste particles go out of a drain to a settling tank, like a septic system, and then the clean water falls through. The next stage, that water that has been filtered by the drum filter goes to a biofilter. So I brought this so everyone can see. I promise it's pretty clean. It has been used, but not for a while, but feel free to grab some and pass it around if you like. This is just media that we add to the biofilter. Now you can use these, which is what we prefer. We use something called a moving bed biofilter. So we add this media to it. But you could also use sand or plastic plates or different things. And the point of this is if you grab one and you're looking at it, you can see it has a ton of little grooves and lots of surface area. And this allows something called nitrifying bacteria to grow on those grooves. So that's good bacteria. If you all heard about eating probiotics like yogurt and things, we want that good bacteria in the system because that converts all the ammonia that the fish release into less harmful forms that are not toxic to the fish. So this is a very important component to these systems. If you've ever had an aquarium at your house that has a filter on it, that's what it's doing. It has a little mesh filter and it builds up all that good bacteria on there. So then the next stage is fractionation. This woman is standing next to a really giant thing we like to call a foam fractionator or a protein skimmer. And what that does, it shoots fine particles through the rest of the water after it's already been through the drum filter and the biofilter. And it gets out any additional protein particles that are left in the water. And then the last stage is UV sterilization. So the water is very clean at that point after it goes through the foam fractionator. It travels through the UV sterilizer and just gets a little extra clean. And from that point it goes back into the tanks and starts the journey all over again. So now I'm going to tell you a little bit about the species that we have on site. I'll start with my favorite, the Atlantic halibut. This is the world's largest flounder. It's a right-eyed flounder. The biggest one that was caught was over 500 pounds. So you can only imagine how huge that is. We have about 100 of these adult halibut on site at the CCAR, and they are what we call our broodstock. So broodstock are the stock of animals or plants that you keep to use as parent stock for future generations. So these are the best of the best. We have one tank of halibut that's about 25 halibut. They're our largest fish. They were caught from the wild and brought in. The other two tanks that we have are what we call F1s, or first generation hatchery reared fish. So their parents were wild fish, but they grew up in a hatchery. So they've only lived in a tank their whole life. Our biggest fish is maybe about 80 pounds. And then our smallest is probably around 10, 15 pounds. The females tend to be larger than the males. So we try to keep a ratio of about 2 to 1 female to male, just because the females make the very valuable eggs and the males make great milk, but we don't need as much of that as we do the eggs to produce a lot of halibut. Halibut aquaculture is not very well developed. It's not very popular around the world because there is one bottleneck, and it's in the larval rearing of the halibut. So they have a very delicate larval stage where their digestive tract just isn't very well formed, and they are sensitive to a lot of bacteria. So you get a lot of loss during that time. I think it's us in the United States. There's one place in Canada, a place in Norway. There was one place in Iceland, but they've since gone out of business. A place in Scotland and a place in Chile. Those are the only places in the world that do halibut aquaculture. So we've had some success in the past, but we're still working to get there to crack that code to what will make us have really successful runs of halibut. So in order to spawn these guys, we actually have to physically get in the tank with them. They're very complex. You put on some waders, jump in the tank, and then we put this table that we specially made. It has a yoga mat on it to protect them from hurting themselves. And we hang it in the tank, and then you have to catch a halibut and kind of gently coax him over to get onto the table. And you have to be very gentle with them because they're strong. They're all muscle, and an 80-pound halibut thrashing around can knock me over. So we get them on the table. We're really nice to them. I'm with them every day, so I really do think they know me. They treat me a little better than some of the other strangers that get in the tanks with them. But I get in, we get the halibut on the table. There's 2 of us in the tank, 1 person outside of the tank, and we check her to see if she's ready. So halibut are batch spawners. They have 2 ovaries and they alternate when they release their eggs. So they'll release one set of eggs and then maybe 3 days later release the second set, and they'll do that 5 or 6 times during the spawning season. So we monitor that and try to catch them when they're going to be releasing eggs, because that's another thing about halibut spawning is the eggs have to be at just the right moment in their development to be fertilized and to have successful offspring. So we get a beaker, gently get the eggs from her. Usually when they're ready, they just pour right out. You don't even have to push on them at all. And we take the eggs, put them in a cooler, then we go and look for a male fish. So we look for the littler fish and get him up there and collect his milk. So that's what we call fish sperm, it's milk. And we take that. Once we have our eggs and our milk, we go into a separate lab and we fertilize them. So it's all done in a bucket, little seawater, some eggs, some milk, mix it up, put it in a cooler, let it sit. And then we rinse them and put them into an incubator. So after about 24 hours or so, your eggs are going to start to look like this. You'll see that cell division. So we keep a little sample of every batch of eggs. And we're looking for 80-90% fertilized. And then that's a good batch that we will keep. This is another tricky part of halibut aquaculture is that to get from this egg to this hatched larvae is 2 weeks. So it's a long time for something to go wrong. And then from this, which is what we call a yolk sac larvae, is this big yolk sac with all its nutrients that it needs to survive. It absorbs that yolk sac and becomes something that can start to eat food on its own. That takes another 45 days. So a huge amount of time in there where something can go wrong. But eventually, if you do everything right, you get these cute little adorable baby halibut. And those are about 2 inches long, and they're ready to sell. So then we can sell those to business partners who want to grow them out for their business. And then we also have some cod on site. We recently did a research project with them. It was all about amounts of CO2 in the water and the cataract formation in the cod. So somebody noticed that all these cod were getting cataracts. And they were thinking, oh, I kind of see a pattern here with the amount of carbon dioxide in the water and the cataract formation in the cod. So we hired a graduate student, a PhD student, and he came on board and he designed with his PI project to look at the cataract formation of these codfish. So it might sound kind of weird and silly, but it has huge implications for aquaculture because just like us, the fish are breathing, exhaling carbon dioxide. So that builds up in their water and causes them to get cataracts. When you go to feed them, they won't be able to see the food. You'll have a poor quality fish. Even if they can find their food, as some of them during our study showed that they could find food even though they were blind. Maybe when they go to market, people aren't going to want that fish because they always tell you to look at the fish eye. In addition to just aquaculture, it has a little bigger impact on something called ocean acidification. So increased carbon dioxide levels in the ocean lead to acidified waters. And that has huge impacts. I'm not sure if you've heard on oysters and things like that, larval development of things like that. So it just kind of shows how changes like that can have a detrimental impact on our environment. So this is my second favorite fish. This fish does not live in Maine. It's native to the Pacific Ocean. It's found all the way from Canada down to Chile, pretty much. Very delicious fish. If you've ever had yellowtail at a sushi restaurant, they call it hamachi sometimes. Very similar to this. So high value fish. And I love this fish because it is really fast at going through all those stages that the halibut is so slow at going through. So I'll go back a sec. So this is a new addition to the CCAR. We got this fish, I want to say in 2013. we were able to go on a rescue mission down to Great Bay Aquaculture in New Hampshire. They went out of business and their power was about to get shut off, and fish living in a recirculating aquaculture system are very dependent on power. So if their pumps stop, they will all die. They won't have any more oxygen. So we got a team together, drove down there, built some tank systems that we could keep them alive on the drive back, and now we have a whole broodstock collection of about 90 fish. And they're all about this big.
Wow.
Really impressive, very strong fish. So we have two stocks at the CCAR. We have one that originated from Chile and one that came from San Diego, California. So here's a little bit about how we spawn and rear them. I told you about the halibut. This diagram on the left, that's pretty much any fish development, but that is a yellowtail development. So they go through, depending on the temperature of the water, those stages very quickly, 2 to 3 days, and they're hatched, which in the halibut it was 2 weeks. The way we get these fish to spawn, you might be wondering that, is we manipulate their temperature and their photo period. So their light schedule and the temperature. And the yellowtail, they spawn at the point where the temperatures are still rising, but the lights start to decrease a bit. And this happens in nature as well. And that's what triggers them to spawn. So we, throughout the year, will manipulate their temperature and their light, and eventually they'll spawn. So we're just starting this. We're going to start a spawning run in September. So we've already had a couple fish prematurely go for it. But that's a good sign, because that means they're happy in their home. So once they hatch and they use up their little yolk sac, that is gone in about a day, really fast compared to the halibut, 45 days. They move on to what we call live feed. So these are just little tiny animals that are small enough for the larvae to eat. And we produce all of those on site at the CCAR. The top is a rotifer, and it's the smallest that we have on site. You can get some smaller if you're producing smaller fish, but that's the smallest feed, and that works really well with the yellowtails. So what we do is we grow them out, manage these populations, and then we feed the rotifer special enrichment diets. So the rotifer is kind of just like a live vehicle for all the nutrients that need to get into that fish. So we feed the rotifer really high nutrient food that the larvae will eventually eat and take in all those nutrients. Once the fish gets a little bigger, they move on to something called artemia. So those, I'm sure you all may be familiar with, they are sea monkeys. If you've ever had a sea monkey in your house. Or brine shrimp. So they eat the artemia, same thing, we enrich the artemia, they get all those good nutrients. Eventually, they can move on to a dry diet, and then eventually they move on to eating their siblings. So this is one I pulled out of the tank. I thought, what is hanging out of that fish's mouth? And he grew a lot faster than his brother and ate him. Unfortunately, he choked on his brother and didn't make it. So that's what he gets.
Would you talk about the size of the rotifer versus the artemia, or when they can actually eat any of them?
Well, they go onto the rotifers immediately after they absorb that yolk sac. So
How big is the rotifer?
it's tiny. I'm not sure exactly of the exact size. You need a microscope to see them.
Okay.
You can see them with the naked eye when they're all pulled together. You see the color of them, but you can't see individual. The artemia, you can kind of see an individual with the naked eye, but you still need a microscope to really.
And how big are the fish when they start to eat fish?
They're about a millimeter or 2, I would say. Very small. These guys are very tiny little black specks when they first emerge. So then we have our invertebrates that we have on site. Sea urchins are pretty cool. They have spikes. We've worked on several projects with sea urchins over the years. The first was just the development of hatchery protocols for sea urchins. So figuring out how you would spawn a sea urchin and make it grow in the conditions it needs to grow. And then the second was the grow out of the small urchins, finding the best diets for them to grow the best, and also something called urchin ranching, where we got a lease site in the ocean, put some little urchins out there, and then came back later to see if they stuck around and could be fished, or if they left the site and found a better place. So that was our second research project. And then our third was trying to figure out the best finishing diets for these urchins to get the best quality gonads. So that's why, the main reason why we produce sea urchins at the CCAR is because it's a popular food. In a sushi restaurant, it's called uni. Not sure if you've ever tried it. It's an interesting flavor. Shimbashi has some. I recommend you go down and get some someday. But it is the gonad. They eat both the male and female. Each sea urchin, you can see inside, has 5 lobes of the gonad. So we actually, our last graduate student, he had a tasting on campus in Orono. So they had posters made and everything. So come be part of our taste trial. And they had to try 4 different samples of uni that were grown in different conditions. They compared it to a wild sample and different feeds that they were fed and different techniques that were used. And so the way we get them to spawn is we actually inject them with a chemical, potassium chloride, and that triggers them to spawn. And you mix just like a fish, mix the milk and the eggs, and eventually you get a little sea urchin larvae. So these are free floating. They live in little cones that gently move them around, and they are fed microalgae, so single-celled algae. And you can see inside of this guy the little green dots. That's all the algae that he's been eating. Eventually, they're ready to settle out, like a sea urchin you may have seen in a tide pool. They settle to the bottom, and we give them some substrate that has some scuzz on it that they like to eat when they first settle. And they settle out, and you can't see them. They're invisible to the naked eye. You need a microscope to see them. But eventually, after a couple months, you start to see these little specks everywhere. And then now, we did this maybe 4 or 5 months ago, and now we have some that you can actually see, and it looks like a little tiny urchin. Another use for these is in education, like science classrooms, marine biology classrooms. They like to dissect these. So food and pretty much that. And then our last species, although we have some others, are these polychaete worms. So do you know what these are used for?
Fishing.
What did you say?
Fishing.
Fishing, fish bait, yeah. So they're pretty high valued, I think like 50 cents a worm for bait. So we figured out how to grow them there. We're also looking at some alternative uses for these worms, like fish meal alternatives. So that's something you may have heard about with aquaculture, is that we're catching all these fish to make fish meal to feed to these other fish. So we're still catching fish to feed to the fish. So people are looking into alternatives. So maybe marine worms like this, or fly larvae, a lot of different alternatives, or plant-based products. And that's what a larval form of that worm. Aren't they adorable? And then another big part of what we do at the CCAR, so that was all of our research and our fish. Another big part is our business incubator. Currently we have 3 businesses on site incubating, but we've had many in the past. Our first is Sea and Reef Aquaculture, then we have a company called Acadia Harvest, and then a company that doesn't have a name yet, but they are involved in seaweed farming and drying and processing. So I named it Sarah's Sea Vegetables because one of the women involved in this company is named Sarah. And we also work with Maine Sea Grant, so we have a sea vegetable lab at the CCAR. So the way you grow sea vegetables, do any of you eat sea vegetables? Seaweed, kelp, things like that? So what you have to do is find a nice reproductive piece of kelp. And I'm not a seaweed expert, but I've worked closely with one, so she's taught me about this. It has like a darker strip on it. And then she takes that into the lab, does stuff to it to stress it out, like puts it in a freezer, and it triggers it to release its spores. And so once it releases its spores, she puts those spores in a fish tank with a bunch of these. So this, you can pass that around if you like, it's just a piece of PVC with a bunch of twine wrapped around it. So all those spores settle out and attach to that twine. And then, once they've grown up a little bit, she gives them some nutrients and the right light that they need to grow. She takes them out to her release site in Sorrento and puts that piece of PVC through a rope that's attached to a mooring and a buoy, and just kind of drives along with the boat, and that unwinds and attaches to that big long piece of rope. And from there, they attach to the rope and start to grow. So that second picture is just the little baby cups growing on the line. And then after a few months, they get bigger and bigger. And in the spring and summer, it's time to harvest. So from what I hear, the biggest bottleneck in kelp production is drying. So their company currently is trying to figure out the best way to efficiently dry kelp. And I know what they're doing, but I can't tell you because it's top secret. So they've had some success, which is great. So once you go out into the ocean, harvest your kelp, you figure out a way to dry it, then you can start to make all these products from it. You can sell it just as a dried product, whole leaf kelp. You can make seasonings out of it. You can use it in cosmetics. I brought some of these if you'd like to try them. These are little kelp crunch bars from Maine Coast Sea Vegetables. Feel free to open them. So lots of different products.
That's from Chef.
Yeah, that's from Chef. That's likely wild, not aquaculture. So then our next company is Sea and Reef Aquaculture. You know Soren?
Soren's actually spoken to us.
Oh, cool. So did you all hear about this?
Not this year.
Oh, because I can skip this.
No, I
No,
don't
no.
know.
Oh, okay. So Soren's the guy right there in the middle, and then those are his two main, his number one and number two right next to him. They're at a conference or a big convention in Washington, D.C. promoting their product. So they look real happy. They love what they do. Soren's been doing this. He's established Sea and Reef in 2003 in his dorm room on campus in Orono when he was a PhD student. He just started growing these fish. And that turned into him moving into a facility on campus there that was a little bit smaller, and then he needed more space, so he moved down to CCAR in 2012, and now he has about 10 employees that spend all day making these fish. And his thing that he likes to do is make these color morphs. So he selects for different color traits and breeds the pairs. So they produce an all-white clownfish, or an all-black clownfish, or a clownfish with really weird patterns. And these are really, really popular in the aquarium trade. And he's so passionate about it because the way most marine aquarium fish are collected from the wild is really detrimental to the environment. So he wants to do something that can alleviate that. And he's doing a great job, and I brought some of his brochures for you. So he talks about all the ways that an aquacultured ornamental fish would be better than a wild caught fish. And one of those that I think is really neat is that they're more friendly. They're not scared of people. They've been around people their whole life. They weren't taken from their home and placed somewhere else. So they are in front of the glass and not hiding behind a piece of coral or something.
I was in there the other day, and as you walk by a tank, they will all come here.
They all, because they think you're going to feed them, right? But they're also just healthier, and you know how old they are. You know the kind of lifespan you should get out of it. So he has a really great thing going. I'm very proud of him. And then this is another company. They started in 2012 at CCAR. They're called Acadia Harvest. And their business is kind of split into two different sections. They do yellowtail grow out. So I told you all about how we spawn the yellowtail, make the baby yellowtail. You're probably wondering, what do we do with those baby yellowtail? well, we sell it to Acadia Harvest. And they buy the seed fish, we call them, just like a seed if you were planting a garden. And they grow them out till they're market size. And they sell them to a wholesaler. So they have a couple spaces on site at the CCAR that we help them maintain, but we kind of lease to them in an agreement, and that's where they do all their work. So one of the places they sell to is Maine shellfish, and I hear that Shimbashi has their fish, and I've been down there and tasted them, so I recommend that you go down and try them. And that's their brand name, Maine Haramasa. So that's their logo that they've created for this fish. All the taste tests that they've had done have shown that this fish has really high quality taste and texture compared to the fish you may get shipped in from Japan. So what they do, it's a different species as well, but they typically in Japan they'll catch the fish from the wild, bring them in, feed them to grow them out a little bit bigger, and then harvest them. So these have spent their entire lives in the hatchery setting. And then the really cool thing that Acadia Harvest is doing, and they just got a huge National Science Foundation grant to do this work, is something called Integrative Multi-Trophic Aquaculture, or IMTA. And that is where you grow lots of different species together in the hopes that the waste from one species gets used by another. And so they're doing something with, yellowtail and worms and macroalgae and oysters, where they're all grown together in one system, with the waste of the fish going to give nutrients to the algae and things like that. So it's really tricky. They have to balance everything, but their hope is to make an entirely closed loop system where they don't have to add any new water to that system, where everything is being recycled. So it's just like a mini ecosystem on its own.
Instead of tilapia.
That's a black sea bass, actually. Kind of looks like a tilapia though. And then what's next for CCAR? So the next thing we're working on right now are eels. So we have some people that are interested in being business partners on site to do eel grow out and figuring out how to grow out eels. So I'm sure you've all heard of the elvers or the glass eels. They catch them here and they ship them off to be grown out to a large size fish. And then some of those are actually shipped back to Maine or to the United States to be eaten in sushi restaurants. So if we can grow them out here, we can cut down on all that shipping back and forth. And it'd be really neat is the life cycle of these eels has not been closed yet. So if we could figure out the life cycle of them, then we could do all the spawning and everything in-house and have a completely self-sustainable system. And then our final thing is what we call the MAT lab. That's the Maine Aquaculture Technology Lab. We have two 300,000 gallon tanks that were existing on site from back when it was a salmon farm. And they were in really rough shape when they took over the site. So they ended up repairing them and building a nice building over it and getting all of the equipment that is needed to run those in a recirculating system. So we think one tank will probably be used for yellowtail and just grow a ton of them in one big tank. And then the other tank is free to whoever decides they want to do something in that tank. You can do projects that mimic the open ocean with little sea cages and things like that. Or you can have a tuna brood stock, so a big bluefin tuna in there to try to figure out that species. But yeah, that's pretty much it for CCAR right now. This is all my contact information, so I want to invite any of you, all of you, to come down for a tour.